Hi, this is the tool demonstrations for the tool Bugs in DLLs or Bugs in Deep Learning libraries. As a part of prerequisites, I have already installed Docker, Conda, and the NVIDIA Container Toolkit on my machine. Also, I have cloned the repository and I have added it to my path. Now I'll go through the commands and how to use them. The list tests commands basically list the available tests or available bug reproduction scripts on the dataset. As you can see, it is displaying all the bug IDs that we have for each library. Show info is used to show info for different bugs. For example, if I want to show the info of the bug ID 120903 for PyTorch, I will just do this. And it displays the info. If I want to run a test, or if I want to reproduce a bug, I will just use the command run test. Here I am using the short forms -l and -i instead of _library name and _bug ID. I could also use the longer names and the results would be the same. And as the bug is getting reproduced, let me go through the other commands that we have. If we run tests on a directory, then it will actually run all of the tests in that state directory. The stats command is going to publish all of the statistics that we have available for the tool. Now our run is done, and by the green check mark and saying that one has passed, we can see that the bug was successfully reproduced. We can also see here what error the bug was talking about. We can see the bug ID, and this is using PyTest, so this is just a PyTest output. As you can see, the exact environment that was used to report the bug was also used to reproduce this bug. Now, I will go through the other feature that we have, which is tool integration. We can integrate different fuzzing tools with the BugsInDLL tool. For example and reference, we have integrated FreeFuzz into the tool. To start with the tool integration, we first need a Docker file, and we need a script that can generate the Docker file and get it up and running. We already have that script for FreeFuzz in the repository, so that is what I'm going to use here. The idea of the tool integration is if we provide the version of a library to this tool, then it will create an environment for that version. It will integrate FreeFuzz into the version. It will run FreeFuzz on that specific version. It will go through all the bugs that can be reproduced with that version, and it will check whether that bug can be reproduced with FreeFuzz or not. This is some of the sample output. As you can see, if I run this command, the sample output will look like this. At the end, it will give me a summary of how many bugs were reproduced. It will also provide some details on which APIs it ran on. We can also instead use a single bug ID if we are targeting a single bug instead of a library version. And the command to do that would be this. That will work in a similar way. And the only difference is for the version, the tool will choose one of the bugs that are available in that version as a reference environment, and it will create the environment from that bug inside the Docker. After that is done and the FreeFuzz tool is run, it will either tell us how many bugs from that version were reproduced, or it will tell us how many, whether the bug that we are targeting has been reproduced or not. To facilitate this, you will have to implement 3 different scripts. These scripts can be found under the tool integration /FreeFuzz folder. The first script is pre-processing Python file. This is basically a tool-specific tool which can go through all the APIs that has to be run. So basically, as you can see here, it will create a file called APIs under test, and it will also create a skip APIs under test, because that's how FreeFuzz determines which APIs to run. That's why this is a library specific or a tool specific script. So you have to write a script like this, which will include the information on which APIs to run, or if any other information is needed for the tool to run. The second script is a post process. This is where you will implement the matching of the bugs. For FreeFuzz, what I have done is I have gone through the output folders. I have taken the execution logs, and I have put that in the list of errors. And in the pre-processing part, I also had the list of errors saved in the Docker. So when the post-processing is done, this error list will include all of the errors that the bugs that we are targeting reproduced. And this code right here will match the execution log with the errors. If you can provide a post-process and a pre-process script, then you'll have to write a script like this, which basically executes the pre-processing function, executes the tool, and then executes the post-processing function. This script is basically meant to have the commands necessary to run a tool and run the pre-process and post-process before that. When we are going to run the command to run this tool with FreeFuzz, we will also pass this script as an input. If we give the run tool command the Docker container that we have, the library that we are targeting, the version that we are targeting, and the script that we are targeting, only then will it be able to generate this log. Now let's wait while the Docker is getting built. As you can see, the requirements are getting installed to run FreeBus inside the Docker. The scripts that are provided in the repository for pre-processing, post-processing, and running the tool can be used as templates. So if you want to include your fuzzing tool and integrate with that with BugsInDLLs, you can just use these as reference. Now it is restoring the database where FreeFuzz saves all of its data. We have successfully built the Docker. Now we will try to run the tool. Now we will show what happens when we run the command to run the tool with FreeFuzz. It is now installing the required environments. This is just the first step where it is trying to reproduce one of the reference bugs that can be reproduced with this library function or the library version. As you can see, it was successfully reproduced. This is done as a sanity check. Now the environment was installed inside the Docker and FreeFuzz is running. These are all the APIs that it is skipping. So the run is over, and as we can see, FreeFuzz could not generate or reproduce these bugs. So the report is telling us that only 0 out of 3 bugs, meaning none of the bugs were reproduced. This is because these APIs are not supported by FreeFuzz. So after seeing this, the developer can decide to add support for this APIs, and they can rerun FreeFuzz to see if they can now reach the target and reproduce the bugs. Now let's go over some other tools. Let's take a look at the statistics tool. So if I do this, it will show me the statistics that we have for the databases. So we have support for 3 libraries, PyTorch, JAX, and TensorFlow. So as you can see, we have 46 bugs for JAX. We can see different statistics about the types of bugs that we have. We can also see what types of bug it has and how we can reproduce them using release builds or nightly builds. This is a breakdown of what bugs can be reproduced with which version. This information can be used to run the tool with FreeFuzz. And this is basically a rundown of where the bugs are. So this is using the pull requests as reference to determine where the bug is rooted. And it is printing a try, showing which file or which source is causing the most bugs. This can also help a researcher to determine where to target a fuzzing campaign, because, for example, this file is responsible for 8 bugs. So fuzzing this file could be a good idea. These similar stats can be seen for PyTorch and TensorFlow. So these are the basic commands that you can run. For a full list of commands, you can take a look at the README. Thanks for watching.